Welcome to lecture 12, everyone. We're going to do joins, which we didn't complete last time, and then we are going to spend the rest of today on table examples using principally histograms, groups, pivots, and joins, just to give us a workout, and I hope by the end we'll have something cool. As always, we start with some announcements. The midterm, Friday, October 15th, 7 to 8:30 p.m. There is an alternate time. There is a form that you should fill out, please, in the next couple of days. And all of the information is on ED. So please check on ED for the most up-to-date information. As always, there's a homework due tomorrow. And as always, if you turn it in today, Wednesday by 11:59, then you get 5 bonus points. Project 1 checkpoint is due this Friday. Now, just please keep in mind that a checkpoint is just a check of progress. You don't have to be completely correct. You can go back and revisit what you have done and change it. You can get a partner from your own lab. The entire project that you and your partner should submit, or you by yourself if you don't have a partner, is due the following Friday. So I'm just going to take 1 minute in the chat for any logistical questions, which are most likely going to be answered better by Will than by me. Is there extra credit for early submission for the project? I'm not going to swear to this. I think the answer is yes. Yeah. The midterm is online. Okay. So the goals for this week, on Monday, you went through group and pivot. You learned to group a table by a single categorical variable, by multiple categorical variables. And then in a particular instance, when you were grouping by 2 categorical variables, you could also use pivot to get a pivot table. Today, we'll combine tables using a method called join, and then we'll spend the rest of the time on a case study. And Friday, we start random sampling, right? So random experiments, and then because we're going to want to sample over and over and over again and do things for every sample, we are going to study what's called iteration, which in some very rough sense means, doing something repeatedly, and sometimes it's based on the answers of what you did before. Okay, so just as a recall, there's always a question about, do I use group or pivot? If you have a single categorical variable and you want its distribution, then you group by that variable. Then by default, you get the distinct values of that variable and all the counts. And so you have a distribution. If you have more than one, and especially if you have more than 2, then you can group by, more than 1. And you get 1 row per combination. If you happen to have exactly 2, then you can also display the data in what is called a pivot table, where you have the variables of 1 going along the column, the values of 1 going along the column and the values of the other going along the rows. So I won't say much more about these in general. As we work through our notebook, you will see uses, and at that point we can discuss questions. Okay, so the main business of today is join. And before we get into details, let's talk about what the situation is in which you might want to join 2 tables. So thus far, we have given you data in 1 table. And you have augmented those tables. You have made them bigger by using with columns. Right? You have created new columns of data where each element in the column corresponds to one of the individuals in your original table. But sometimes your data, you gather it from multiple sources. So you get a table from here, and then you get a table of related data from somewhere else. And the people who gathered those data have not been talking to each other. So their variables are labeled differently. They have slightly different conventions for what they have done. The sizes of their data sets are different because they were interested in different variables. Still, you may have two tables that are related to each other, and you might want to put the data together. And in some situations, you can do that using a method that is called join. Let me take a moment to, the bears, yes. Credit our GSIs for all of our graphics. The logo you saw on the title slide was also made by one of the GSIs. All right. So here we have two tables which we made up. One of them is called, so these are representing 3 tea coffee houses in Berkeley and drinks that you can get with them and alleged prices. Though if somebody has actually got an espresso at the Strada for $1.75, take me with you next time. So here are two tables. The first table has each row corresponding to a drink that somebody bought. And there's the name of the drink, there's which cafe they bought it at, and the price. Separately, somebody else gathered some data about the discounts offered, coupons offered at these tea houses. Strada offers a 25% coupon for this, according to this table, and Asha offers 2, a 10% and a 5%. And so now looking at this, I think it's very reasonable to think, okay, look, if I have these two tables, I should be able to quickly produce another table that tells me what these drinks would actually cost if I apply the coupon. And so I have to put the 10% and the 5% together with the Asha lines and the 25% with the Strada lines. And you know, free speech movement didn't have a coupon. So I don't know, I have to make some decision what I do about that. And this we will do by using join. And the call goes like this. You take the table drinks and you join it. But you have to figure out what to join it by. Now, what is common to the drinks table and the discounts table? Just in English. Yeah, so in one case, it's being called location, and in the other case, it's being called cafe. But what is common to both tables are the names of these restaurants. So what we're going to do is we're going to say, okay, every time I see an Asha in the drinks table, I'm going to look for an Asha in the discounts table. And every time I see a Strada in the drinks table, I'm going to look for a Strada in the discounts table. And so the call is, you take a table of drinks, you join it by the cafe column to the discounts table, and where you're looking in the location column for what's common to cafe. And that's a long mouthful, but let's just see in a picture what happens. That is what you get. And now we should take a look at what we have there. So here we have a row which says that Asha had a milk tea for $5.50, and here we have a row that says Asha has a milk tea for $5.50. But now we also see that Asha has a 10% coupon. Can somebody explain to me why we have the second row? Because Asha appeared only once in the drinks table. Why does it appear twice, do you think, in the joined table? Because there are two different coupons. And so the join method has made a decision that it will join your Asha row with every other ASHA row that it finds in the discount table, and that is why there are two. For Strada, there is only one row to join with in the discount table, and so you can see both of them have 25%. Somebody asked, what happened to FSM? Well, FSM had no coupon. The join method has decided that it is not going to include tables that rows that it does not find a match in the second table. You could say, well, what if I wanted to include it? Then that would be a different kind of join, and I would suggest that you take data 100. I remember teaching 4 or 5 different kinds of joins there. Okay, so there are some questions that I'd like to answer. If the FSM had a discount, then you could add a row to discounts and put in that coupon, and then you could join, but the two tables do not have to be the same size. So what is happening is you're matching rows in the first table using values in the columns that you specify. These are the values that are going to match in your second table. So the second argument is the name of your second table, and then you have the name of the column where the matches are. And so you get a table that has columns from both tables, but notice that the location column is not there, right? What the method does is it says, look, the location column, those are the identifiers that I'm matching through Caffe. I have the Caffe. I'm not going to use I'm not going to provide the location as well, because it would be doubling the same information. Okay, so for example, if you have the Latte Strada row, then that gets matched with the 25% Strada row, and in the end, you get the combined information. Okay. Some of you will have noticed that there is a sorting that has happened here. I'll come to that a bit later. The joined column is sorted automatically. Let me just take a look at the questions that are being asked. Okay, what's FSM, the Free Speech Movement Caffe? So what we're going to do now is look at a demo where we run through all of this and we examine these questions in detail. Okay, so here is your drinks table, just as it was on the slides. Okay, I have a question for you. Should I make the font a little bit bigger? Anyone? Is it legible? Okay, I'll continue that. So there's your drinks table and there's your discounts table. And so now we are going to do, okay, to the drinks table, we're going to join by the Caffe column, what was the other one called? Discounts table. And there we're looking for matches, Caffe matches in the location column. And this combined table is what you saw in your in the slides. So now, the point of this was to see, can I write down, how much do I actually have to pay for these drinks if I apply these coupons? So, well, if you have a 10% off coupon, then what percent are you paying? You're paying 90%. All right, so it is quite natural to to 100 minus Yep, but that's a percent. So if I want a fraction, because I'm going to have to multiply by the fraction, then I should divide by 100. Are we okay with what has been computed there? Ah, thank you. I would have got an error if I had uppercase. Okay. And so this would give me 0.9 from the 10%. And so what do I have to do now? I have to do so I have to take the price column, and then what do? I multiply it by these fractions. And I see what I get. And there I have my prices to an extraordinarily precise degree. I hope we have many fractions of cents. But the point of this is that once you have joined your two tables, you have a little more flexibility to do calculations by using the table methods that you already know. So what I'd like to do now is take a closer look at the joined table that we got here. Okay, and one thing you can see is that these rows appear to be in alphabetical order of the cafe names. And so what I want to do is I want to start with a version of the table that drinks that we had before. I'm calling it drinks 2. It has the same rows, but in a different order. So we start with the Strada, and then we have Asha in the middle, and we have FSM. And I remind you that we have discounts. Okay. If we join these two tables, so I will take drinks 2 and join it again by the It's Cafe column to the discounts table using the location column for the match. Let's see what we get. Okay, what are you noticing? Yeah. You're all correct. You're noticing alphabetical order. The cafe column is sorted, and somebody said Strada appears twice. That's also correct. It put cafe as the first column. That is also correct. That's all very sharp observations. Let's look at our previous joined table. Notice that the column that you were joining by was also put first there. Yep. And so what we are seeing is that the join method is sorting the identifiers that you are joining by. So the one way to imagine it is that if you take, this is the cafe column that you are joining by. First, imagine it's sorted, so Asha comes first. So you look at this row, this is an Asha row. You look for an Asha row in here, you see an Asha 10 row, and you get that joined row. But you keep going down this look to see if you have exhausted all the Asha rows. You have not. Here is another Asha row. So you have the Asha 5 row. And so you still have your Asha row from your original table, and you join it with the Asha 5 row. And then you have that, and then you have the Strada Latte row and the Strada Espresso row, because that's the sequence that you had it in the original table. So there's a little bit of sorting that happens there. Okay, a couple of notes on column names. Let me just remind you of the original table. That was drinks, and I'm going to make now a tiny little table that says what these drinks were. And why don't we join drinks with our new table? What have I called it? With what column should I join? Yes. And it's the cafe column of the drinks new table here that I want to join by because it has the names of the cafes, what is happening here. Okay, that's better. Okay, now the reason for doing this is you notice that in the two tables you're joining, there's the column drink both of them have a column called drink. So now the question is, do I get two columns called drink? Because that'll be extremely confusing. So what the method does is it relabels this drink column in the second table by calling it drink 2. It had to make some decision, and that's the decision it made. So that is worth noting. Another thing worth noting is this line. Has a repetition in that the names, the labels of the columns in the two tables that I'm joining, the columns by which I'm matching happen to have the same label, right? Both are called cafe. If you want to be lazy, you can leave the second one out. And what join assumes then is that it is to look for a column called cafe in the second table. And if it doesn't find one, it will be unhappy. All good? So let me pause for a second and take some questions. Justin, try it out. Yeah, actually, I'm not 100% sure that whether you get an error or an empty table, but either way, you'll not get anything useful. Removing that last argument makes the function look for the same named column in the other table to match by exactly. Jinu. You can. We did before. Right, if you look at this line here, we had the second column name, and if you compare with this line, you get exactly the same table. All right, so one of the things I want to do now is to really look at the difference between join and with columns, because we are very used to increasing tables by with columns by now. And so the column that you add to the right end of your table has the same size as your original table, and its elements correspond to each individual in your original table. But join can do something quite different. And for this, I want to show you an example using a table that you have seen before. This is a table from the census, and you remember we had some discussion about the sex categories, where 0 meant everyone, and then they had a 1 and a 2. They only had 2, and you could only select male or select female, and you had no other options. Is this something that you remember? Okay. So the sex column there has 0, 1, and 2 in it, right? What if I wanted to have the descriptions of what those meant as a column? Then one of the things that I need to do is actually create what the descriptions are, and I happen to create them in a table. Okay, notice that the first table has 300 something rows. This is simply definitions of my 3 numbers, what 0, 1, and 2 mean in the sex in the sex column in the census table. Let's see what happens if we join the 2. And now, what is a reasonable thing to join by? What's common to these 2 tables? Yes. Sex in one of them and sex code in the other. So for, I'm in the wrong place. Okay, here. In the sex codes column, I need to, my identifiers are in the sex code column in my sex codes table. And in the census table, those identifiers can be found in the sex column. And if I join, then everywhere there was a sex code of 0, it now gets an all as the definition of the code. And while we're about it, why don't we just take a look at this whole thing? And at some point, we're going to switch. And everywhere there's 1, you get selected male. And everywhere there's 2, you get selected female. What determines the order of the columns? Okay, that's a good question. Let's take a look at that. So what join will do is it includes your first table, the table to which you are applying the method join first. So you have sex code and code definition. And then you get the columns of the other table. So that is my census table in order, but it leaves out the column of identifiers because that identification information is already in the sex code column. Micah, did I answer your question? Yeah, go ahead, follow up. Okay, I'm going to continue. I'll come back. Okay, so we're now ready to do an example using a pretty large data set. I'm going to show you the data set. This is a data set that we collected, well, that is provided publicly by the San Francisco bike sharing organization. And it has the data on every trip on the bikes of that organization for a year. And so we're going to load this table. Now I'm going to tell you, this table is huge. So I actually don't know how it's going to work if you all try to download it at once. Professor David, if you would please advise on the chat, that would be most helpful. Thank you. Okay, so see, it's loading and it's a lot of data. And look, 350,000 rows. That's a lot of rows. That's a lot of trips. Okay, so each row of this table represents one trip, right? Somebody picked up a bike at one station, rode it, and dropped it off at another station. So the trip has some ID. This is some identifier. It's anonymous. This second thing is the duration of the trip in seconds. So if I go down, this 126 seconds is about a 2-minute trip. Okay, there's a start date, there's a start station, there's an identifier for exactly where it was picked up, there's an end date, there's an end station, similar identifier, which bike it was, and then etc. a bunch of information. And so there's a lot of data, and when you have data like this, it swims in front of you, it's a good idea to just start small and say, okay, you know what, I'm just going to examine one of the variables. And, duration is interesting. How long did these trips last is an interesting thing to do. So what we'll do is we will look at the distribution of durations. And somebody tell me, please, what visualization can I use for this? The distribution of these durations. What is the appropriate visualization to use? Histogram. Terrific. Thank you so much. It is a quantitative data set. So, okay, here we go. Just absolutely basic call to hist. Just give it the column name. And we get a really dumb histogram. Okay, that is like the least informative histogram. By the way, it is correct. But correctness by itself is not the only virtue. It happens to be also completely useless. Okay, so what is going on here? What's going on is that we didn't specify any bins or anything. So HIST does what it always does, which is it goes from the smallest value to the largest value, which clearly there was some trip that took many seconds. And then it tries to make 10 equal bars in that range. And well, most of the bars you can't see, and you get this one humongous bar, and it's totally useless. Okay, so let's do better than that. Let's actually see first, before that, if I'm right in that there was one huge trip. Let's just see. So why don't we look, what was it called? Trip. So I'll sort it by duration and look for the biggest one. Oh dear, that's a lot of seconds. Right, we're talking in the millions of seconds, and let's just look at the start date and the end date. This thing, somebody started writing in 2014 and they stopped writing in 2015. Do we really think that they were writing for a year? So what were they doing? Somebody suggested something kind, which is that they forgot to return it, or they returned it later. Yes, a less charitable explanation has been provided before, that perhaps it was stolen and then found, whatever it was. That thing is an outlier, and there's a few others like that, right? So let us just not include those very unusual long trips. What we'll do is we'll just look at the trips, just for the sake of today's lecture. We'll just look at the trips that are below half an hour, okay, and draw a histogram of those. And now you see a distribution. All right, so there's a right-hand tail, which probably goes on for a long time if we included all of the data, but now you see a distribution. There is something a little bit annoying about this, because while I see the numbers 250, 500 is actually in the middle of this. I'm not sure exactly where these bins are, because HIST is making its own decisions about where to put the edges of the bars. And so I just went ahead and specified equal bins 250 seconds wide. And while we're about it, I specified the unit as well. So now this is something that is possible for us to read. And so let's just remind ourselves that we know how to work with histograms. Can somebody tell me how what percent of the trips were in the 250 to 500 range? What feature of the histogram will tell us that? So the histogram has two axes. It has a horizontal axis, a horizontal scale, a vertical scale, and it has area, right? If I want the percent in the bar, what do I need? I need area, exactly. I need area, so I'm just going to eyeball this thing. Roughly 0.15 as the height, and what's the width? So I have 0.15, and then the width is 500, right end minus left end. And approximately 37.5 is what I think that is. Okay, so take a look at that histogram again. Can you tell me whether that 37.5 is going to be an overestimate or an underestimate? Take a careful look. Underestimate, why are you saying that? The bar goes just about above 0.15. Yes, my eyeballing is a little bit rough there. So if instead, what did I call this? Commute. I call this commute. Yes. If I try to calculate this exactly, R between includes the Now look, it's taking some time because it has to go through a lot of rows, and then I compare that to the total number. And I have 38 and a bit percent. Okay. So as you said, my 37.5 was a slight underestimate. Okay, this is just histogram review. What I'll do is I will draw the histogram again, and now I'm going to do something, which is, look, we have a ton of data, but we have a very crude representation of the distribution because we've taken bins that are very wide. We've taken bins that are 250 seconds wide. Why don't we just take, and that's like 1, 2, 3, 4, 5, 6, 7 bins. That's a small number of bins. Let's see what happens when we ask for 60 bins. Bins equals number means give me that many bins. Okay, now take a look at that. Okay, you see something that is beginning to look like a curve. And the reason we can do this and still get a histogram that is legible is we have so much data that there are data at lots of different values. If you have a very small data set, or you should not ask for tons of bins because you'll get a very strange looking histogram. What I'd like you to do is to look at the two horizontal axes. You agree that they are exactly the same? Okay, now look at the vertical. What do you see? Look at both the units of measurement and the values. Same or different? Exactly the same. Because you're working with densities, you have already scaled percent per second. The scale is exactly the same. It is the same physical area of 100% that is represented slightly different, that is represented differently in the two pictures. The first one being a very crude representation, and the second one being more precise. Yes, the bins are different, but the percent per second is the same. Now, this bin is very narrow, so it'll have a very small percent. But if you look at the percent in the 250 to 500 range, you will get the same thing that you got previously. Okay, so that's a little bit of a histogram review. Let's take another look at the data set. Here we have the start station. If I wanted to know which is the station that people most commonly start at, what method would you use? Okay, bar chart would be to display, but how would I find which station people most commonly start at? Yes, group is a very good, we have to find the count, exactly, we would group. Okay, so we would, group, sort, honestly. Looking better? Or do I still have to fix something? It's got a group, a very big table. When I used to lecture in person, we used to hum the Jeopardy tune. Okay, so no surprise, one of the Caltrain stations was the highest. And then you have the ferry building and so on. Okay, for the numbers of trips between stations, we are going to use pivot between stations. So start station to end station. Okay, before I run this thing, can somebody please tell me what this is going to give me? You're going to get a 2D table, right? What's going to be in the body of the table? In each cell, what am I going to get? I'm going to get a count. Exactly. I'm going to get a count. I'm going to get a count because I haven't asked for any other way to collect the data. So let me run this, and we'll talk while we're running it. And while this thing is running, I will okay, here we go. So we have the start stations along the columns here because I specified start station first. We have the end stations along the rows here because I specified end station second. I didn't ask Pivot to do anything else specifically, so it does what it does by default, which is it simply counts how many rows, that is how many trips fell into each of these cells. And I want to look at a big one. Can I find a big one? Here we go. Starting at the ferry building, 2,600 trips, starting at the ferry building and ending at 2nd and Townsend. Does anyone know what happens at 2nd and Townsend? Anyone been there? What is there? I'm realizing that you guys haven't been here a lot, have you? Okay, it's near the ballpark. And in those days, people went to games. AT&T Park, exactly, Cal, that's right. Okay, so here you have a table that gives you the number of trips. What if I wanted the average duration of trips between these stations? Then what would I have to do? Well, then I would have to say, work on the duration column and do what to it? Average it. Okay, while that's moving, I have a question for you. We have a bunch of, we have another couple of pivot examples, but given the time, okay, so let's just finish this. Okay, so now what happened here? We pivoted in the same way. We said, okay, label the columns by the start stations, label the rows by the end stations, but now don't just count, do something to another column. So take the duration column, and in each of these cells, there were a bunch of trips. Take the durations of all those trips and average them. So what we have here in the cells are not counts, they are measured in seconds. Now, somebody tell me why there is nothing here. This is Almadane, and 2nd and Folsom is in San Francisco. Where's Almadane? Does anyone know? Too far, yeah. It's in the South Bay. Remember that we restricted to trips that were half an hour or less. And I think even the fastest person cannot bike in that way. All right, so I'm going to take a pause now and ask you a question. There are a few more examples like this in your notebook. Would you, should we move to maps instead? What do you think? Okay, tell you what, let's move to maps instead. And then if we have some time we'll come back. So what I said was, we'd have data from some other source. And here are data geographically about the stations. They're physical locations. Okay, so what I'd like to do is just reduce these data. So what is it? This is an ID for the station. This is the name of the station, latitude and longitude. Landmark is a very weird title in this table for what is really a city. Okay, so what we're going to do is just distill this table down to the pieces that we need to draw a map. So naturally, we're going to need the latitude and the longitude. I am going to restrict just to San Francisco for ease of viewing the maps. Okay, so I'm going to start picking only the rows where the landmark is equal to San Francisco. And then I'm going to pick the latitude, the longitude, and the name, and bear with me. For our maps to work, the name column has to be called labels. So I'm going to show you what happened there. We selected San Francisco, and then 3 of the rows, and then 3 of the columns, and we changed a column label. Instead of name, it says label. So lat, long, and labels. Now I'm going to use a method marker.mapTable to this table here. Are we ready? Those questions? All right. Ta-da! Okay, maybe I can zoom in. Looking good? All right, so what happens if I click right here on this marker? It tells me which station it is. That is what the marker is doing. It's telling me which station it is. Okay, so this is a marker table. You can also do a circle. You can also mark by circles. And here, here it just seems like I've lost information. OpenStreetMap, exactly. OpenStreetMap. Now, if you look at that, you will say, wait a minute. We've just lost information, right? But you see, circles are geometric figures, and you can size the circles to represent numbers at the particular station. So for example, we already have we know where most of the trips started. So we could resize the circles proportional, with the area proportional to the number of trips. And now I have exactly 1 minute. Okay, I will remind you that we created a table of all the starts. And so, the Caltrain station had the highest start. This we did before. We also have stations, and notice they have a column in common. There is the names of the stations. So we are going to join the geographical data with the start data, and we are going to get one table that has all of these. And then we're going to do some munging so that the table has for each station, the latitude, the longitude, the labels. It requires a colors column, don't ask me. And the areas corresponds to the number of trips. Okay, here we go. As the campanile is ringing, this better work. Okay. And now you have circles, some of which are bigger than others. Obviously, there are scale issues here that you have to that you have to deal with. I will say that circle.map table is a work in progress. That is why I said, don't ask me. I think this needs a little bit of attention. However, you can see how these things are developed. I am going to stop now and I'm going to hang around for your questions. Thank you all for coming, and we'll see you Friday.